Welcome back, my calculus students, my wonderful calculus students. This is 2012, question number 3. Let's do it. Okay, notice this is F, and we're told it's continuous, so there's no holes or jumps. We have line segments and a semicircle, so those are the shapes involved, and we're given the function g. So let's do part A. We want g of 2. Well, you plug that into the function they gave us. That's integral from 1 to 2 of f of t dt. Well, how do you find that? Well, from a graph, to evaluate an integral, it's the net area. So what's the net area of that? Since it's below the x-axis, it's going to be negative. So I will put in a minus sign. And the area of that triangle is 1/2 base times height. Well, the base is 1, and that height is 1/2. Now, if you want to figure out why that's 1/2, if you look clearly, that's 1 and that's 2. So the slope of that's negative 1/2. So if you go over 1, which that's 1, you're going to go down 1/2. So that's what's going on there. Let me erase all that. So hopefully you heed my warnings. You should reread the question and make sure you finish answering it, and we have not. They also asked us to evaluate g at negative 2. So that's going to be integral from 1 to negative 2. That, again, is going to be a net area, but we're going backwards. I want to point that out. We're going from 1 to negative 2. So when you do that, your answer is going to be opposite of what it normally is. So it's going to be minus the net area. Or there's another way to look at it here. Let me change colors. So normally that, you find that net area, or that area. Normally that would be negative because it's below, but since we're going backwards, it's going to be positive. And then we need the area of that triangle. And normally, again, that would be positive, but since we're going backwards, it's going to be negative. So that's why I put the negative here to make them opposite. So the triangle on top is going to be, the area that's going to be 1/2 base times height. The base is 1 and the height is 3. And then, now again, I'm putting minus here, but remember that because of the minus here, with that minus, actually adding that area. So you can not put the minus in front and just do it automatically. Either way, you'll get the same answer. So what's the area of a circle or a semicircle? It's pi. The radius is 1, but it's a half a circle, so you divide by 2. All right. So that is the answer to the part A. Let's go to part B. So B, they want us to find g prime at negative 3. Well, to find g prime at negative 3, I need g prime. So if we look at this, I need to find g prime. So let me actually do this. Let me erase this. The first thing you should find is g prime of x. So again, let's look at this. Fundamental theorem of calculus. We're taking a derivative from a constant to x of an integral. All you do is plug in x in for t. So that's going to be just f of x. So you have to understand the fundamental theorem. That's just f of x. So then they're asking us for g prime at negative 3. That's going to be f at negative 3. If we look at the graph, f at negative 3 is going to be the value there. Let me use a different color. That y value is f at negative 3. Now to make sure, if you want to be careful, that rise goes from 1 to 3, that's 2, and that run is 2, so the slope's 1. So we're going to have a 1, 1 here, so clearly the y value there is 2, and you kind of see it there. But to be technical, just be careful on that. Okay, next I need g double prime, because I want g double prime at negative 3. So if g prime is f of x, g double prime would be f prime of x. So from that, we want g double prime at negative 3. So g double prime at negative 3 will be equal to f prime at negative 3. All right, so how do we find that? So it's going to be at the same point that we just did. I will circle it in a beautiful green. So we want the derivative at that point, but we know the derivative is the slope of the tangent line. The slope of that line is clearly 1, so the answer is 1. We're done with part B. Let me erase all that junk I put in there. Okay. Part C. Find the x-coordinate. So they want the x-coordinate where G has a horizontal tangent line. So to say that in English, that's saying the derivative of G is 0. That's what it's saying. So find that. For each of these points, determine whether G has a relative minimum or relative maximum or neither. All right, this seems very doable. So part C. You want to know when g prime of x equals 0. Well, look at the graph. G prime of x equals 0 where? Negative 1 and 1. Oh, why is that? Okay, earlier, I will explain. Earlier we said g prime is f of x. And that equals 0, clearly at x is negative 1 and 1. So to determine whether it's a relative max or min, you have to see what the derivative does. So again, we want to know if g, whoa, that doesn't work. We want to know if g, so we need to check what happens to g prime. So we're going to make a table of what happens around negative 1 and 1. So I can do negative 2, 0, and 2. And I want to know what's happening to g prime, which is f. So f at negative 2 is positive, f at 0 is negative, f at 2 is negative. So let's get our conclusions here. When f changes from positive to negative, that's a rel max. And here there's no sign change, so it's neither. So we need to write our conclusions out. G has a relative max at x equals negative 1, and the reason? Because g prime of x changes from positive to negative at x equals -1. And then at 1, there is no sign change, so there's neither a relative max or min, and you could say G has neither a rel max or min at x equals 1. And again, because G prime of x does not change sigens. All right. Oh, at x equals 1. All right, last part. Part D. So in this interval, we want points of inflection. Oh, wow. Wow. Let me cover all this. Man, this part, once you get it, it's easy. It's easy. But some of you... Okay, I'll explain it on the picture, and then I'll write out all my reasoning. So they want to know if G has a point of inflection. Now, I just want to remind you of some stuff here. We already figured this out earlier. G prime of x is f of x. And then G double prime of x is f prime of x. So a point of inflection occurs when the second derivative changes signs. So we want to know the sign of G prime of x, which is f prime of x. G double prime of x, which is f prime of x. So how do we get the sign of f prime of x? Watch this. How do you know if the derivative of f is positive or negative? That's a simple justification. If f is increasing, f prime is positive. So in this region here and in this region here, both of those, f is increasing, right? So therefore, f prime, which is G double prime, is positive. Now let's look at this section from here to here and here to here. On those regions, f is decreasing. If f is decreasing, its derivative, which is the same as G double prime, is negative. So we're going to use basically what I just drew there. We're going to write that out and get the sign of the second derivative. So here let's do blue. Okay, we'll do the red. Actually, I'm going to do red because we're doing the red parts of the graph. So since f is decreasing on, and there's two intervals, from -2 to 0 and increasing. Lame-o, Yoshida, lame-o. Wow, I was going to write it again. Increasing. And it's going to be from 0 to 1. Therefore, f prime, which is G double prime, is positive. Now I'm going to do the purple part, the decreasing. Since f is decreasing on, and what intervals were they? -2 to 0. No. Oh my Yoshida. Let's go back. Put some of your... Wow. I don't... Whoa. Whoa, we're in trouble here. We're in trouble. I don't know why it's bleeding from the bottom. Okay, here we go. Let me fix all this ugliness. Sorry. So it's increasing from -4 to -2. -4 to -2. Whoa, 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 whoa. And 0 to 1. Okay, that's better. Everything's mucho better. Okay. So f is decreasing. Now this is from -2 to 0. And 1 to 3. Therefore, the derivative of f, which is g double prime, is negative. So now we know where g double prime is negative and where it's positive. And we see that it changes signs at -2 and at 1 and 0, 3 places. It changes signs, and I'll show you. Here, here, and here. And you can just look at these intervals. So it changes signs at -2, at 0, and at 1. So, therefore, G has inflection points at x equal -2, 0, and 1 because G double prime changes signs at those points. Bam. Done. Dunno, dunno, dunno. Are we done with all parts? That is so cool. All right, we're done. That's the last video for this assignment. I hope you're having a great day. And I'll be back in a couple of days.